Hi class, in today's lesson we're going to be looking at linear function forms. So just as a review, a linear function is just a function rule that represents a line. And so with linear functions, they can be written in a variety of different ways. And one of the most common forms used for writing linear functions is known as this form right here, the slope-intercept form. Now, slope-intercept form, if you were to look at it as a function rule, looks like this formula right here. Now remember, you can either write it as y equals or f of x equals, and it means the same thing. So we have this formula, y equals mx plus b. And so what we fill into some of the variables will determine the behavior of our function rule. And if you recall, in the last lesson, we talked about the formula for slope. And so we had the variable m, which represents our slope value. And then we have a new variable we're going to introduce here. This b value is going to represent what's known as our y-intercept. What a y-intercept is where the function crosses the y-axis. So take a look at this example of a linear function down below. Now, the function rule is not written out, but what we can do, we can use the information in this graph over here to help us to determine what the linear function rule would look like. So we're going to look for a couple different things anytime we write a function rule out based off of a picture of a line graph that we receive, a graph of a line. So one of the things you're going to look for is the y-intercept, so where it crosses or touches the y-axis. And so it touches the y-axis at this value right here on the y-axis at positive 2. So that would be our b value. Now, to find the slope, if you remember, it's delta y over delta x. So pick 2 points on your graph, on your line, and then measure your delta y, so your change in y, and then compare that to your change in x. So it's up 2 and write 3 units. Now, one of the neat things about slope is that you can follow that same pattern all the way up. So up 2, write 3 units, and then up 2, hang on a minute, make sure I'm measuring this right, then up 2, write 3 units again. And so we get points all along the same line. So our slope is equal to 2 over 3. So how do we write our function rule out? So off to the side, we write our formula for slope-intercept form, y equals mx plus b. And then we fill in our given pieces of information. So remember, our m value is the ratio 2/3, x, and then we fill in our y-intercept at positive 2. And there you go. So that's how you write a linear function in slope-intercept form. Here are some practice problems down below. So the directions tell us to write an equation of a line in slope-intercept form and to use the given information down below to set up your equations. So you'll notice here with all 4 of these problems, I give you an m value and a b value. So it's just a matter of plugging it in correctly into your slope-intercept formula, which again is y equals mx plus b. So you're just going to use this setup here and just make sure you plug in your information carefully. So it's pretty straightforward. So for number 1, the answer would be y equals 5x. And you could write plus -7. Let's just write -7 just to make it easier right there. Number 2, y equals -1/2 x plus 5 over 2. Number 3 would be y equals -3x minus 8. See that right there? And then number 4, y equals 2/5 x plus 4. So as you can tell, when you're given the slope and the y-intercept is actually very straightforward in terms of plugging everything in to make sure you have the correct answer for all of them. So it's pretty straightforward to do. Now, of course, you'll run into word problems and even graphs of of lines where it's not as straightforward, but you can just use the context clues to help you to set up your lines in slope-intercept form. For this next example, what we're going to do is take a graph of a line and pick out information from the graph in order to write it in slope-intercept form. Sorry for the poorly drawn line. I should take art class again. Now, if we take a look at what we have right here, one of the first things that we always identify is where is the y-intercept, the b value. So that's where it touches the y-axis. So it touches the y-axis at +1. Now, let's figure out what our slope is. As you recall, it's delta y over delta x. So all you need to do is pick 2 points on your graph and then measure the delta y and the delta x. So the change in your y value goes, it looks like goes down 1 unit, and then the measure across the delta x is over 3 units. You see that? So down 1, right 3 units. So -1/3. So negative divided by positive will be a negative slope, so you could just write your slope like that. So the final result would be -1/3 x plus 1. Hope that made sense. So remember that when you're measuring slope, the easiest process will be just to go from left to right on your graph, because you'll notice that as we go from left to right, we're going down 1 right 3 units every single time, and we're hitting every single point on that line along the way. To graph a line in slope-intercept form is actually really easy to do. If you know what the function rule is, like we'll look at in this example here in just a moment, there's only 3 key steps you need to remember. The first thing is to plot the y-intercept. Second, use your slope to locate another point from the y-intercept. And then the third and final step will be to draw a line through your 2 points, and then you are done. So let's take a look at this example as a practical application. So here we have this function rule, f of x equals -2/5 x plus 3. So the first thing we're going to do before we do any of the steps is identify our slope and our y-intercept. So our slope is, we pick that out from the number, the value before the variable, which is -2/5. Now if you want to, since our slope is negative, just go ahead and move that negative up to the top number right there, and that's going to help you out with your rise over run here in just a moment. Now our b value is this number after the variable term, which is just +3. So now we have our key pieces of information. Let's use that now to create our graph. So remember, step 1, we're going to plot our y-intercept, which is at +3. So remember, always start at the origin, 1, 2, 3, right there. So there is our b value. So step 2, use your slope to locate another point from the y-intercept. Don't start at the origin again, start at the b value that you just plotted. So we're going to apply our slope. So we go down 2, then right 1, 2, 3, 4, 5. There you go. And of course, if you need to, you can put little dotted lines in to help you out. We're just making sure that you're doing your rise over run measurements correctly, just starting out the first couple of times. So now we've got our 2 points as a reference. So all we need to do now is hopefully draw a straight line, there we go, through those 2 points. There we go. There you go. So as you can see, it's really easy to do. So it takes a little bit of practice, but as you can tell, if you follow those 3 steps, very easy to graph a line when your function rule is in this form, slope-intercept form. And so the great thing about this is that if you remember in the past when we graphed function rules, I had you made an XY table. And so this bypasses all that work that's needed to create an XY table and pick values to test for X. But if you follow these basic rules here, you can draw a line every single time. I hope you found this information helpful. Let me know if you have any questions, and I'll be glad to help you out. Have a great day.